Union of sets introduction. So, in mathematics, a set is simply a well-defined collection of distinct objects. What does well-defined mean? It means that it's clear whether or not something belongs to the set. And distinct means that each object within the set is unique, no repetitions allowed. Think of it like a specific group of items, clearly identified and with no duplicates. Now, here's a key idea. We don't just see a set as a list of things, we treat it as a single object in itself. This might sound a little abstract at first, but it allows us to perform operations on these sets, just like we perform operations on numbers. And that brings us to the core of this tutorial. These operations allow us to combine or manipulate these collections of objects. We'll be focusing specifically on one such operation, the union of sets. The union is a fundamental concept in something called set theory, which is a branch of mathematics that deals with these kinds of collections. Let's begin our exploration of sets and their operations. Welcome to this tutorial on the union of sets. Before we dive into the union itself, it's important to understand what a set actually is. Over the next few slides, we'll break down exactly what the union of sets is, how to find it, and how to visualize it. We'll start with a simple way to represent sets, called roster form, and then move on to using diagrams to help us understand the concept visually. So let's get started. What is the union of sets? Here's the core idea. The union of two or more sets creates a new set. This new set includes all the elements that are present in any of the original sets. So, we're gathering everything together into one big collection. Now, a really important rule. No element is repeated in this new, combined set. Even if an element appears in multiple original sets, we only list it once in the union. Think of it like this. Imagine you have different groups of items, maybe a box of red blocks and a box of blue blocks. The union would be like emptying both boxes into one big pile. You wouldn't count the same block twice, even if it happened to be in both boxes originally. We want a list of distinct items. Now, mathematicians like to have symbols to make things concise. The symbol we use to represent the union of sets is this. Union. It looks like a curved U. And if we have two specific sets, let's call them A and B, then the union of A and B is written as a union B. So, we simply write the sets, with the union symbol in between. This tells us we're combining all the elements from set A and set B into a single set, remembering to avoid any duplicates. So let's move on to understanding exactly what the union of sets is. As we discussed on the previous slide, sets are just well-defined collections of objects. Now, when we want to combine these collections, the union is one of the ways we do that. In the next few slides, we'll practice finding the union of sets using a method called roster form, where we actually list out the elements, and then we'll also see how to visualize this using Venn diagrams. But for now, make sure you have a solid grasp of this definition. The union combines everything without repetition. Finding the union of sets roster form. So let's move on to actually finding the union of sets. Up until now, we've discussed what the union is conceptually. Now we'll look at how to calculate it. First, let's recall how we represent sets. This slide introduces the roster form, also known as the list form. Essentially, this just means we write out all the elements of a set, placing them inside curly braces. So, if we have a set containing the numbers 1, 2, and 3, we'd write that as 1, 2, 3, enclosed in curly braces. Now let's look at example 1. We have two sets. Set A, which contains the numbers 1, 2, and 3, and set B, which contains the numbers 3, 4, and 5. Our goal is to find a union B, and remember, the symbol for union is a U shape. So, we're looking for everything that's in either A or B or both. To do this systematically, we follow these steps. First, we simply list out all the elements of set A that's 1, 2, and 3. Next, we list out all the elements of set B that's 3, 4, and 5. Now this is the crucial part. We combine these lists, but we need to remove any duplicates. If we just wrote everything out, we'd have 1, 2, 3, 3, 4, 5. But remember, in a set, each element is distinct. so we only write the 3 once. Therefore, when we combine and remove duplicates, we get 1, 2, 3, 4, and 5. So, a union B, which we write as a UB, is equal to the set containing 1, 2, 3, 4, and 5, enclosed in curly braces. This is the basic process for finding the union of sets in roster form. We'll see another example on the next slide, and then we'll explore how to visualize this using Venn diagrams, which can be really helpful, especially when dealing with more complex sets. Finding the union of sets roster form, continued. Let's move on to another example of finding the union of sets. This is still using the roster method, which, as we discussed, means we're simply listing out the elements. Now on this slide, we have 2 new sets. Set C and Set D. Set C contains the elements B and C, and Set D contains the elements C and E. To find the union of C and D, which we write as C union D, we follow the same steps as before. Remember, the union combines everything from both sets, but we only include each unique element once. First, we list out all the elements of set C, that's B and C. Next, we list out all the elements of set D, that's C and E. Now, this is the crucial part. We combine these lists and remove any duplicates. So, we have a B, C, and E. Notice that C appeared in both original lists, but we only write it once in the combined list. Therefore, the union of set C and set D, written as C union D, is the set containing a B, C, and E. We represent this as a set with curly braces, a B, C, D, E. This reinforces what we learned earlier. The union brings everything together, but avoids repetition. In the next example, we'll see how this works with more than just 2 sets, building on the same principle. Finding the union of sets roster form, more than 2 sets. Let's move on to another example, this time dealing with the union of more than 2 sets. As you've seen in the previous examples, finding the union isn't limited to just 2 sets. We can extend it to any number of sets. Here we have 3 sets, P, Q, and R. Set P contains the elements 1 and 2. Set Q contains the elements 2 and 3. And finally, set R contains the elements 3 and 4. Now, to find the union of all 3, which we write as P union Q union R, we simply combine all the elements from each set into one big group. Let's do that step by step. First, we list the elements of P, 1, 2. Then we list the elements of Q, 2, 3. Next, we list the elements of R, 3, 4. Now here's the crucial part. Just like before, we need to remove any duplicates. If we just listed everything out, we'd have 1, 2, 2, 3, 3, 4. But remember, in a set, each element is unique. So, after removing the duplicates, we're left with 1, 2, 3, and 4. Therefore, the union of P, Q, and R, that is, P union Q union R, is the set containing 1, 2, 3, and 4. We represent this as 1, 2, 3, 4. This demonstrates that the process for finding the union remains the same regardless of how many sets you're combining. You simply list all the unique elements from all the sets. In the next slide, we'll explore how to visualize this using Venn diagrams, which can be particularly helpful when dealing with multiple sets. Finding the union of sets, Venn diagrams. So far, we've been working with sets and finding their union by simply listing out all the elements and removing any repeats. Now, let's move on to a more visual way to understand the union of sets, using something called a Venn diagram. Now, the area where the circles overlap, that is, the space that's inside both circles, represents something called the intersection of the sets. We'll be covering that in detail shortly, so don't worry too much about it right now. Just know that it represents the elements that are common to both sets. But for now, what's important is this. The entire area covered by all the circles, meaning everything inside circle A, everything inside circle B, and especially that overlapping part, that represents the union of the sets. It visually shows you all the elements that are in either set A, set B, or both. This slide introduces the Venn diagram. A Venn diagram is essentially a picture that helps us visualize what's going on with our sets. It uses overlapping circles to represent the sets. Imagine you have a circle, and you label it A. Then you draw another circle that overlaps with the first one, and you label that B. The way these circles overlap is key. We'll see this in action on the next slide with a specific example. But this slide is just laying the groundwork for understanding how Venn diagrams can be a really helpful tool when working with sets and their unions. It gives you a quick, visual way to see what the union looks like without having to write out all the elements. Finding the union of sets, Venn diagram example 1. So on this slide, we have two sets to find. A and B. Set A contains the numbers 1, 2, and 3. And set B contains the numbers 3, 4, and 5. Remember from the previous slides, the union of A and B, which we write as a union B, is a new set containing all the unique elements from both A and B. We already calculated that a union B is equal to the set containing 1, 2, 3, 4, and 5. Let's move on to visualizing the union of sets using Venn diagrams. This will really help solidify our understanding. Now, let's see that visually. The first step is to draw two circles that overlap. Think of these circles as representing our sets. A and B will label one circle A and the other B, so we know which is which. Next, we need to place the elements of each set within the circles. Let's start with set A. The elements unique to a meaning the elements that are in A but not in B are 1 and 2. So, we write 1 and 2 inside the part of circle A that doesn't overlap with circle B. Now, let's do the same for set B. The elements unique to B, meaning in B but not in A, are 4 and 5. We write 4 and 5 inside the part of circle B that doesn't overlap with circle A. Now, this is important. Notice that both sets A and B have the number 3 in common. This is where the overlapping region comes in. We write 3 in the area where the circles A and B overlap. This shows that 3 is an element of both sets. Finally, to represent a union B, the union of A and B, with the Venn diagram, we simply look at everything inside both circles. That includes everything in the non-overlapping part of A, the non-overlapping part of B, and the overlapping region. As we already determined, that gives us the set containing 1, 2, 3, 4, and 5. So, the Venn diagram visually confirms what we found using the roster method. The union of A and B is the set containing all the unique elements from both sets. In the next slide, we'll recap the key takeaways from this entire tutorial and also look at some common mistakes students make when working with unions. Key takeaways. First, remember that the union of sets takes all the elements, all the individual items, from the sets you're combining and puts them together into one single set. Think of it like merging different groups of things into one big group. Now, a really important point. When you're creating this new, combined set, you absolutely must remove any duplicate elements. If an item appears in more than one of the original sets, it only appears once in the union. We want a collection of distinct objects, remember. As we've practiced, there are a couple of ways we can actually find this union. We can use what's called the roster form, where we simply list out all the elements within curly braces, or we can use a visual tool called a Venn diagram, which we just explored. Both methods will give you the same correct answer. And finally, let's not forget the notation. The symbol we use to represent the union of sets is union, which looks like this. If we have two sets, let's say set A and set B, then their union is written as a union B, so A, then the union symbol, then B. Let's recap what we've learned about the union of sets. This slide summarizes the key takeaways, so pay close attention. Keep these points in mind, as we'll be building on this foundation when we start looking at other set operations, like intersection, in the next section. Also, the next slide will highlight some common mistakes students make with unions, so it's good to have these key takeaways fresh in your mind. Common mistakes. First, it says, forgetting to remove duplicates. A common mistake is listing all elements from each set without removing duplicates. Remember, the union contains each distinct element only once. Now, we've been through several examples, like combining set A and set B, and if 3 appeared in both, we only wrote it down once in the final union. It's really crucial to remember that the union isn't just about writing down everything, it's about listing each unique item. If you list the same element multiple times, you haven't correctly formed the union. Next, it points out, misinterpreting Venn diagrams. Ensure you include all elements from both sets when using Venn diagrams. The entire area covered by the circles represents the union. Remember those diagrams we just looked at? The union is represented by everything inside both circles, the overlapping part and the non-overlapping parts. It's easy to focus only on what the sets have in common, but the union includes everything from both sets, so make sure your diagram reflects that complete coverage. Finally, and this is a big one, confusing union with intersection. It's easy to confuse the union, combining all elements with the intersection, finding common elements. Always remember the definition of each operation. We haven't formally covered intersection yet, but you'll learn that it's about finding what's shared between sets. The union, on the other hand, is about combining everything. So, if the question asks for the union, don't accidentally list only the elements that are in both sets. That would be the intersection. Keep those definitions straight, and you'll be in good shape. Let's move on to the final slide, which highlights some common mistakes students make when working with the union of sets. Paying attention to these will really help solidify your understanding. So, that wraps up our tutorial on the union of sets. Remember the key takeaways. Combine all elements, remove duplicates, and you can use either roster form or Venn diagrams to find the union. Be mindful of these common mistakes, and you'll be well on your way to mastering this important concept in set theory.